here are a couple of other workouts from Unit 1, and in these two examples I try to do a visual interpretation for you to make some connections with the trig functions. All right, our first problem, if sine t is equal to -2/7 and is in quadrant 3, find all of the other trig functions. What I want you to do is notice that I've just drawn a very simple coordinate plane, because in order to do this, if you can visualize it, you will have a much better understanding. So what I want to think about is down here in quadrant 3, I'm going to have the hypotenuse of my triangle, or the radius of my triangle. This will be angle T that I'm looking at. It's formed again with my x-axis and my radius, or my hypotenuse. And then what I want to think about is I'm going to have a vertical piece and a horizontal piece. I can actually put values on my triangle now. If sine is -2/7, that means for angle T, the opposite would be -2, and the hypotenuse would be 7. With that done, I can easily see that if I get the value of x, I'll be able to have all of my other trig functions. Setting this up, though, on a diagram helps you see it better. Not only do you know that if it's in the third quadrant, the y value is -2, the x value will also be negative, and you won't even have a problem identifying the signs at the end. So real quick, we would just do a run-through now of Pythagorean theorem. And if you go through and use Pythagorean theorem to solve for x, you're going to end up with perhaps x squared is equal to 45. X is going to be the square root of 45, and this is where we would say not positive or negative. We would just want x to be the negative square root of 45 because we're working in the third quadrant. I would probably do one more step here and say -3 times the square root of 5. With that complete now, you have all of the information that you need in order to set up all of the trig functions. We already have sine. Let's take a look at cosine. Cosine t is going to be equal to the adjacent over the hypotenuse. So that's my x value, -3 square root of 5 over 7. If I next wanted to look at secant, the secant of t, remember, is the reciprocal of cosine, so that would just be 7 over 3 square root of 5, and we'll assign that negative to the top, -7 over 3 square root of 5. If I wanted to look at cosecant, cosecant is based on the reciprocal of sine. The reciprocal of sine would be -7/2. Next, tangent. If we're looking at our right triangle again, the tangent is simply going to be the opposite over the adjacent. Therefore, the tangent would be -2 over -3 times the square root of 5, which reduces to 2 over 3 square root 5. Our cotangent is just going to be the reciprocal of our tangent. Therefore, our cotangent would be 3 times the square root of 5 over 2. I hope that you see from this example, by drawing it, you're going to have a lot more luck in nailing those values. We'll take a look at one more. If cosecant t is equal to 5/3 and t lies in quadrant 2, find the other 5 functions. So you may want to pause this and see if you can set it up by yourself before you see me do it. What I'm going to do first is I'm going to go ahead and outline or highlight quadrant 2. So there's quadrant 2, and in quadrant 2 I'm going to go ahead and draw in a radius. Hypotenuse, however you like to think about it at this point. Remember, the angle T that I'm looking at is the angle that is made between the radius or the hypotenuse with the x-axis. So there's my value of T. The next thing that I would want to do is drop down my vertical piece, and then show my horizontal piece. And remember, that's where your right triangle is formed, right? Because here's your right angle. I know that some of you have been thinking about this a little awkwardly, but there's your right triangle setting up. So one of the things that you know is that the cosecant of t is equal to 5/3. Well, if the cosecant of t is equal to 5/3, I know that the sine of t is the reciprocal of 5/3. The reciprocal of 5/3 would be 3/5, and immediately I would know the vertical piece, or the opposite, and the hypotenuse. Immediately I know that this value is 3 and this value is 5. The only thing left for me to determine is the x value. We've worked with these triangles enough. We know that the x value, this is a Pythagorean triple, the x value would be 4, but it must be -4 because I'm in the second quadrant. As soon as you see that that value is -4, the rest of this is easy. Let's do cosine. The cosine of t would be the x value, or the adjacent, over the hypotenuse, or -4/5. The secant is going to be the reciprocal of the cosine, so the secant is going to be -5/4. The tangent is going to be the opposite over the adjacent. I would assign the negative to the top of the fraction. The opposite is 3. The adjacent is -4, so that would be -3/4. And then the cotangent would be the reciprocal of the tangent, or -4/3. Hopefully these two examples will give you a better understanding of how you can resolve these triangles if you put them in the coordinate plane in their appropriate quadrant. The signs will come out the way that you need it to. Good luck with these, and let me know if I can help you any further.